So in the last video, we started talking about the relational data model, and we introduced some vocab, like a table is called a relation. It has rows, and the rows are also called records, and it has columns, and the columns are called attributes. So in this video, we're also going to start introducing more vocab to get to know more about the database design process. So you've probably heard me in past videos talk about entity. And when we talked about how we start the design, we said the first thing is that we try to get an external view. And we talked to many people to get the external view. And we said that different people that we talk to in different departments will have different external views. Now, we said that the first step after the external view is coming up with the conceptual model. And in the conceptual model, what we said we should do is get a list of all the real world objects that we need to be representing in our database and the relationships between them. So that real world object, we don't refer to it as the real world object in database world, we refer to it as the entity. So when I say, when I go and I talk to people and they say, well, we have students and we have parents and we have teachers and we have classrooms and we have computers, we think of the classroom as an entity, the students as entities, the teachers as entities. So an entity is just basically the object in the real world that we are going to be representing in our database. It could be something that physically exists and you can touch, like a customer, employee, a product, or it can be a conceptual object like a job or a course or a job position that you are representing in your database. Now, that's the entity, that's the real world object. What is the type of the entity? We call that the entity type, and that just refers to the table name. So the table name is the entity type. So if I have here a student, that means the student is the table name. What is it storing? It's storing students. So entity type and entity are kind of sometimes interchangeably used. And an entity set is basically a collection of entities of a type at a particular point in time. So if I talk about the beginning, maybe a week before the semester starts, I want to know all the students that are enrolled in my course, and I run a query and I get that list of students. Maybe I have 22 students. That is called the entity set. At the end of the semester, I might run another query and get the entity set, which contains the collection of students that are still in the course, because maybe some people withdrew or dropped the course. So an entity set is basically a collection of entities of a type. So we can talk about the entity set of students who got an A in the class, the entity set of that got a B, an entity set that got a C, and so on. And so entity sets might contain different entities of the same type. When we talk about different entities, we want to talk about their strength, because it's going to make a difference when we're creating those entity types or their tables in the database. So we say that an entity is strong if it can exist independently from all of its related entities. So for example, if we look at the database that we have in our, that we've created, added the SQL, let's just look at the department table. So here, if I look at all the departments in my database, I will find that the department just contains the department ID and the department name. This department, I can create a department without creating any other entity. So if I wanted to just create departments in this database, I can. It doesn't depend on anything. Let's also look at customer. Here, again, customer, when we look at the columns in the customer table, we will find that they don't depend on anything. It's just adding a bunch of customers. You give them a unique ID, you have their information there. So this is called a strong entity. It doesn't depend on any other entity. Well, what is not a strong entity? So let's look at an entry that is not strong. It's a weak entity. Let's look at employee. Here, if I look at the employee table, I will find that in the employee table, I have a reference to a department ID. So I cannot start inserting these employees into the table if I don't know their department. So I need to first create the department table, And then I can start creating the employee table. The employee table depends on the department. The department table doesn't depend on anything. And so we say that the department table or department entity is a strong entity. The same way with the customer table, we say that it is a strong entity because it doesn't depend on anything. It is independent. Okay, so we call them strong entities. Okay, we also call them independent entities because they don't depend on anything. We can also call them kernels. Now, what would be a weak entity? A weak entity is one that cannot exist independently. It depends on something else, like we saw the employee table, or here the customer order table. It stores a customer ID, a product ID, so it's depending on the customer and a product. You can't have a customer order if you don't have a customer in your system. You can't have a customer order a product if that product is not already in the system. So we say that this is a weak entity because it depends on the existence of other entities. So it is called a dependent entity, or we also call it sometimes a derived entity. It's derived from other entities. Okay? And we will find that those weak entities will have foreign keys. So if someone gives you a description of a table, you can look for something called the foreign key, and we'll talk more about foreign key in future videos. But basically, a foreign key means I am storing a reference to an object in another table. If you're storing a reference to an object in another table, that means this object must exist before you. And if you depend on an object existing before you, then you are a weak entity. You are a dependent entity. So here the customer order table depends on the customer table, and it depends on the product table because it's storing a customer ID and a product ID. So that is the difference between an entity that is strong and an entity that is weak. And so when we talk about dependent entities, which are the weak entities, sometimes they are used to connect two kernels together. They are used to connect two strong independent entities together. So here I have the customer order table. Basically I have, let's go to our database. So we know that we have a table of customers. Okay, so this is storing all the customers that are in our system. We also have a table of our products. So all the products that we are selling are stored in this database, you know, a product ID, a product name, price, and department. And then we have at the end another table called the customer order table. And that customer order is storing every customer what they ordered. Now, every customer can purchase many products. So here, if we look at customer 5, for example, they purchased product 6, and they purchased product 7, and they purchased product 5 and 4. So they purchased many products. Okay. On the other hand, a product is purchased by many people. So product 2 was purchased by customer 3, product 2 was purchased by customer 7, product 2 was purchased by customer 2. So we say the relationship between the customer table and the product table is a many-to-many relationship. We will talk more in details about the types of relationships, but for now, it means that many customers can purchase the same product, and many products can be purchased by the same customer. So that kind of relationship, the many-to-many relationship, cannot be represented in one table in a relational database. So a relational database that we are using in Oracle and we're using in this course has a limitation. And the limitation is that it cannot store those many-to-many relationships. And that is why the object-oriented data model that we kind of discussed briefly is coming and evolving because of that limitation in the relational data model. And so here, this table, customer order, the main reason for this table is to store that many-to-many relationship. What each customer bought, and it can have extra attributes, like here we have an order date, and we can have like order total. So it's storing information from those two tables to represent the many-to-many relationship. In addition, it can store other attributes as needed. And so the way we know the table that the information is coming in from is from using that foreign key. The foreign key here is telling us that this customer ID column is coming from the customer table, and it refers to the customer ID column or attribute there. Now, when we're creating this dependent entity, we have three options for the primary key. So remember, we said every table has to have a primary key. Every table has to have a column that uniquely identifies each row in that table, each entry. And so the customer table has a customer ID column to uniquely identify each customer. The product table had a product ID to uniquely identify each product. Now, when we're placing an order, we need a unique ID for that order. So, we can look it up later. So there are three options. The first option is just creating a new primary key. So this is what we did here in this database. We created a new column called order ID, and we made that the primary key. Okay. What we could have also done is use a composite of foreign keys of associated tables. So we could have said the customer ID and the product ID together are the unique identification for this customer order. Now, this is not always possible. If a customer can only order a product once in their life, this might work so that, you'll know that this customer ordered this product in February of 2018. But if a customer can order a product several times, that means this table might contain the customer ID and the product ID several times. So in that case, it would not work as a unique key. It's kind of like looking at a student taking a course. If a student takes a course only once in their lifetime, then we can store the student ID and course ID as the primary key of a table. But in reality, a student might have to take a course more than one time. Maybe the first time they took it, they had to withdraw. Maybe the second time they took it, they had a bad grade and they wanted to improve the grade. So if the composite of the foreign keys can be unique, we could use that. If it's not, of course, we can't use that, and we can go with a new simple primary key that we create. What we could also do is use a composite of the foreign keys and an additional column. So for example, we could say, well, a customer might order a product, yes, many times, but they will probably not order it, not order the product twice on the same day. So if we take the customer ID, the product ID, and the order date, that will be unique. Well, again, that's not true. I might order a product in the morning and in the afternoon say, I think I need another one of those products, so I go and order another. So with an order for a customer, it's probably not valid. But if you think of a course, a student cannot take a course more than once in a semester. So I could probably use the student ID, the course ID, and maybe the semester, like fall of 2019 or fall of 2018 as my as a primary key. So a primary key, the unique way of identifying a row in a table, can be one column, one attribute, basically a simple primary key that you create yourself, or it can be a set of foreign keys if those are unique, or it can be a set of foreign keys in addition to another column or two that uniquely identify a row. So basically, when you're trying to pick a primary key, you need to make sure that however many columns it is, it will uniquely identify a row in your table. Now, there are different other entities that can exist. So we talked about dividing entities into being strong entities or weak entities, basically independent entities that can exist independently, or dependent entities that rely on the existence of others. There are other entities that we can also use, which are called characteristic entities. And those are ones that provide more information about another table. Let's look at an example. For example, if I look at an address, someone's address, I can store someone's address in the same table. Let's look at our customer table here. Let's go to our customer table. and look at how they are storing the address. So here they are storing the address. Well, actually, they're only storing the address state. They're not storing the full address. But imagine that I had to store the full address. Here I would have the customer ID, first name, last name, and then I would have many, many columns, like here, the first, the house number and the street number and the city and the state and the zip code. I might have a column for each one of these. Another more useful example is looking at a passport. So let's imagine that I have a passport. And let me just open up a notepad to start typing some notes. So imagine that I have a list of customers, or I'm an airline reservation. So let's talk about airline reservations. So I'm an airline reservation company. So I am American Airlines, for example. And I have some reservations. So in my table of reservations, I want to say that this customer is flying from a certain city and they are flying to another city. Okay, and I need to store about this customer. So I have their customer name and I have the customer passport information. Now, if I think of passport information, that passport information contains a lot of things. Let's think of what information is contained in your passport. Well, of course, it contains your name. It contains the place it was issued. It contains the expiration date. It contains the passport number. So every passport has a number. Okay. Now, if I'm looking at the table of reservations, do I really want to see all this information about the passport in the table of reservations? Probably not. I want to see, this customer has a reservation maybe on, the flight number. And because flight numbers sometimes are not unique, I might put a date and time there. Okay? I might put also the destination and where it's coming from. Okay. So maybe this is the main information that I really want to see in the reservation table. But I do need to know that this person has a valid passport so that I can make sure that they can travel. Maybe I need a list of the visas that they have. Okay, the country of issue, well, place of issue is enough, country. Okay, so I need to know this information, but I don't want to save it in the table of reservation, even though it is associated with the table of reservation. So what I can do in this case is create a passport table, and that passport table will store all these columns in addition to the customer's name, for example, or unique ID. So we call that passport table, we would call this passport table a characteristic table. Why do we call it a characteristic table or a characteristic entity? Because it is adding extra information about the customer that exists in another table. So basically, a characteristic entity is a table. It's an entity, but we said an entity is just a table. So a characteristic entity is just a table that has extra information that I want to store about another entity. And these usually come with one-to-many relationships. So if you think about a customer, they have they could have many addresses, like, if you're storing like different shipping addresses in your Amazon. Sometimes I want to ship to my home address. Sometimes I want to ship to my mom's address. Sometimes I want to ship to a friend's address. So those can come from a one-to-many relationship. That is one way to do it. But of course, they can come from a one-to-one relationship, like the passport example that I gave you. So here, another example with the one-to-many relationship is that you can have a course, and one course can have many sections. So you can have a table that describes all the sections of a course. When we have those characteristic entities, we will need to make sure that we store a reference to the actual object. So the foreign key is used to identify that table. And so how can we come up with a primary key for those tables? Well, we can use a composite of either the foreign key and a qualifying column. So this is an example of, this is referring back to the sections of a course. So let's say I have here a list of courses that I have in the system. So here is a list of courses. Okay, so each course has the course name, the CRN number, and maybe the faculty that is teaching, other stuff. And then we have a sections table. Now here in the sections table, I need to know the course name that I'm referring to, and then I also need to know the CRN. Here the CRN number would not be stored in the course. The CRN number would be stored here in the section table. The course name, and then sometimes we have a section number also. Okay. Now here, if we look at the sections table, what could be the primary key? Well, the CRN alone can be a primary key, right? So if you give me the CRN number, I will know exactly which section you want to join. Is it the Monday, Wednesday section, or is it the Tuesday, Thursday section, right? I can know. So this is one option. So this is one option for the primary key, just creating an extra attribute that uniquely identifies this section. Now, let's say we didn't have the section number, the CRN number. In that case, I need to know the course name and the section number. Those two together can be the primary key. So this is the second option. So the second option is having the course name and section number, as the primary key. So if you tell me I want the Java CSC 127 Java course with section 1, I will know that that's the Monday, Wednesday section. If you tell me I want Java 1 section 2, I will know that that is the Tuesday, Thursday section. So again, when we talk about primary keys, just like we talked about primary keys for other tables when we were talking about the dependent entities, the dependent tables, we said that there are 3 options for the primary key. The same options exist when we are talking about characteristic entities. We could have a unique column that we create and make that our primary key, or we could have a second option where we have the course name and section number. And so here, course name is a foreign key, and it refers to the primary key in another table. So here, course name would be the primary key, and here it would be a foreign key. So here it's called. That is what this slide is describing for us.